An escalator moves up at a constant speed connecting the first floor and the second floor. Sven and Oli walk up the escalator. Sven climbs 50 steps per minute and Oli climbs 30 steps per minute. Sven reaches the second floor in 30 seconds and Oli reaches the second floor in 45 seconds. How many steps are visible when the escalator is not moving? Alright, well this is a rate problem, and you guys probably know that the distance is equal to the rate times the time, okay? Assuming that you are working with a constant rate, which we are, because Sven and Oli are both climbing at a constant rate of 50 and 30 steps per minute, and we can assume that the escalator is also moving at a constant rate. Okay, it says it's moving up, alright, and we'll assume that it's moving at a constant rate. Okay, so when Sven and Oli climb this escalator, their rate, here Sven is 50 steps per minute, his rate is boosted by the rate of the escalator. Alright, so relative to the escalator, he's walking at 50 steps per minute, but then the steps are moving up at a certain rate. Alright, and one of the things that might throw you, oftentimes when we do distance, rate, and time problems, we're working with distance in some measurement like inches or feet or meters or centimeters or something like that. But in this case, our we don't know how tall the steps are, so our distance is in steps. So D, our unit of measurement, is steps. Okay, so that might throw you a little bit, but that's okay, because units are kind of arbitrary. We just want to be consistent. So in this case, our distance is in steps. And the distance that Oli and Sven travel, they're both going from the first floor to the second floor, so their distance, the total distance that they travel, is equal. So what we can do is we can take Sven's rate, which is 50 steps per minute, plus the rate of the escalator. Alright, that's going to give us his total rate, because his rate is boosted by the rate of the escalator. We take that times the time, and we're actually given the time too, because Sven reaches the second floor in 30 seconds. And another thing to be careful of is our units have to be consistent. Okay, so we have steps per minute, so our time has to be in minutes. Otherwise, we have to convert this to steps per second or something. So you see how we have our time in seconds, but our rate is in steps per minute. So we have to convert. It's probably easiest just to convert the time into minutes. So the time in this case is half a minute, okay, because it's 30 seconds. And so that's just rate times time. And that's for Sven. I could probably label this. So this is Sven. Now let's look at Oli's rate and time. So Oli climbs the steps at 30 steps per minute, and he is also boosted by the rate of the escalator, because it's also moving up, and he takes 45 seconds to get to the second floor. Alright, so 45 out of 60. Okay, that's the same thing as 3/4. Okay, we can divide both by 15 essentially. Alright, so he gets to the second floor in 3/4 of a minute. Okay, so we had to convert Oli's time to minutes as well. So we have consistent units between the rates and the times. And now you can see this is a pretty straightforward equation to solve, because we only have one variable. We have this RE, rate of the escalator. Okay, so we could say let RE be the rate of the escalator. Okay, so let's solve for the rate of the escalator. First thing I want to do is just get rid of the fractions. So I'm going to multiply both sides by 4. Okay, so I'm going to multiply the whole thing by 4, so the equality still holds. So now I have 2 times 50 plus RE is equal to 3 times 30 plus RE. Okay, I just multiplied everything by 4. And now let's multiply through. So we have 100 plus 2RE is equal to 90 plus 3RE. Okay, we're getting there. Let me scroll down so I have some more room to work. And let's subtract 90 from both sides. So I get on this side, I get 10. And then the 90 minus 90 goes away. Subtract 2RE from both sides. So 3RE minus 2RE is just RE. So the rate of the escalator is 10, and that's in steps per minute. Okay? So it's moving up at a rate of 10 steps per minute. Alright, but that's not what we're looking for. What we're looking for is how many steps are visible when the escalator is not moving. Okay? Which is equivalent to asking what is the distance between the first and second floor in steps. Okay? We don't know how tall the steps are. Steps, I think, are usually about 8 inches, but we don't know how tall the steps are. So, but we're not asked for the distance in inches or meters or anything like that. We're asking for they ask for how many steps are visible. Okay, so we're just looking for the distance in steps. So now that we have the rate here, and we actually have 2 equations for the distance in steps. Okay, we could either plug it into 50 plus RE times a half, or we could plug it into 30 plus RE times 3/4. So let's just plug it into the first one. So we'd have 50 plus 10 is 60 times a half. That looks like 60 and a half, but that's 60 times 1/2. So that means we have 30 steps. So that's the distance between the first and second floor in steps. So if the elevator were stopped, you should see 30 steps between the first and the second floor. Okay? And you'll get the same answer if you were to plug in 10 here into the 30 plus 10 is 40 times 3/4 is also 30 steps. Okay, so this is our answer. There are 30 steps visible when the escalator is not moving.